Good morning, all of you. Today we continue the chemical thermodynamics. Last time we see the Hess law and applications of the Hess law. We see the statement of Hess law, then examples of Hess law, and then applications. Today we see the problem on Hess law. The problems on the Hess law is very simple. If ज्याचं स्किन ऑब्झर्वेशन आहे त्याच्यासाठी या टाईपचे प्रॉब्लेम सोडवणं फार सोपं आहे. म्हणजे कसं आहे, जर तुमची तीक्ष्ण नजर असेल आणि त्या प्रॉब्लेममध्ये काय दिलेलं आहे याच्यावर तुमचा प्रॉब्लेम तुम्ही सॉल्व्ह करू शकता. आता अशा टाईपच्या प्रॉब्लेममध्ये तुम्हाला म्हणजे काय पाहिजे, ॲडिशन, सबस्ट्रॅक्शन, मल्टिप्लिकेशन अँड रिव्हर्स रिएक्शन या गोष्टी तुम्हाला बारकाईने पाहिजे असतात. आता हाच प्रॉब्लेम आपण बघूया काय करायचं. हियर द प्रॉब्लेम ऑन हेस लॉ. कॅल्क्युलेट द स्टँडर्ड एन्थाल्पी ऑफ द रिएक्शन. And a reaction is given here. Twice Fe solid plus 3/2 O2 gas gives out Fe2O3 solid. And they are given the first reaction. Twice Al solid plus Fe2O3 solid gives out twice Fe solid plus Fe2O3 solid. And check standard enthalpy of reaction is equal to minus 847.6 kilojoules. And here second reaction is given here, that is twice Al solid plus 3/2 O2 gas gives out Al2O3 solid. Standard enthalpy of reaction is equal to minus 1670 kilojoules. हा प्रॉब्लेम आपल्याला काय करायचा आहे, सॉल्व्ह करायचा आहे. हे इक्वेशन आहे, हा गिवन डाटा आहे, दोन रिएक्शन दिले हा गिवन डाटा, आणि या डाटावर आपल्याला काय करायचं आहे, हे इक्वेशन फॉर्म करायचं. इक्वेशन फॉर्म करण्यासाठी हा डाटा आपल्याला केअरफुली पाहावा लागेल आणि मग त्याच्यावर हे इक्वेशन कसं फॉर्म करता येईल. तर या इक्वेशन मध्ये काय होतं, हा रिएक्टंट आहे, दिस इज द रिएक्टंट and this is the product. Reactant and product. Here the reactant is twice APS plus 3/2 O2. हे आपल्याला गेट करायचं आहे फ्रॉम दिस डाटा. कसा करायचा, तर पहिलीच रिएक्शन पाहू त्याच्यामध्ये twice Al plus Fe2O3 solid gives out Fe twice Fe solid plus Al2O3. इथे Fe आहे, हा इथला रिएक्टंट आहे, तो इथला रिएक्टंट आहे. म्हणजे हे आपल्याला काय करावं लागणार आहे, लेफ्ट साइडला घ्यावं लागणार आहे, रिएक्टन्सच्या साइडला घ्यावं लागणार आहे. मग कसं घेता येईल, तर काय करावं लागेल, हे इक्वेशन नंबर 1 आहे, काय करावं लागेल, रिव्हर्स. मग लिहायचं फ्लोइंग सोल्यूशन. रिव्हर्स द इक्वेशन फर्स्ट. reverse the equation first. इक्वेशन फर्स्ट काय करायचं, रिव्हर्स करायचं. लिहू आपण त्या पद्धतीने. twice Fe solid plus Al2O3 gives out twice Al solid plus Fe2O3 solid. And here standard enthalpy of reaction delta H0 is equal to, here minus 847.6 kilojoules. And reverse this value means 847.6 kilojoules is the reverse value of it. Then this is the equation first. We reverse the equation first. Then we got this equation from these two equations. Then we see the second equation, twice Al plus twice 3/2 O2 gas gives out Al2O3. जर आपण हे इक्वेशन आयएनसी च्या मध्ये घेतलं तर काय होईल? या एला हा ए कॅन्सल होईल. त्याच्यानंतर हा इथं आपल्याला 3O2 आहे, 3O2 मिळेल. मग काय करू? ऍड द इक्वेशन सेकंड इन इक्वेशन फर्स्ट. Add equations second in equation first. Add proper equation. Twice Al solid plus 3/2 O2 gas gives out Al2O3 solid. Then delta R, the standard enthalpy of reaction is equal to minus 1670 kilojoules. And add this to equation. Add this to equation. And net equation is get from this. Here twice Al, cancel this twice Al. Then here Al2O3 we cancel. What is remaining? Here twice Fe solid plus here 3/2 O2 gas gives out Fe2O3 solid, and then the standard enthalpy of reaction is equal to, here is a plus and here is minus, subtraction of these two, and we get minus 822.4 kilojoules. And here Cl twice APS, here twice APS plus 3/2 O2, 3/2 gives out Fe2O3. Now we got this equation from these two equations, and here we solve, and standard enthalpy of this reaction is this. here आपल्याला इथे काय करायचे होते, या इक्वेशनचे हे स्टँडर्ड एन्थाल्पी ऑफ दिस रिएक्शन फाइंड आउट करायची होती. तर या प्रकारे किती व्हॅल्यू -822.4 किलोजूल्स. अशा टाइपचे प्रॉब्लेम तुम्हाला काय केले जातात बोर्डाच्या परीक्षेला 4 मार्कला किंवा 3 मार्कला विचारले जातात. याच्यावरती सीईटीला क्वेश्चन असतो, जेईला क्वेश्चन असतो, नीटला क्वेश्चन असतो. हे सगळे या टाइपचे प्रॉब्लेम तुम्ही काय करायचे सॉल्व करत जायचे. We see the next point, that is entropy and spontaneity. What is the relation between entropy and spontaneity? You know that entropy means to measure a randomness or disorder by thermodynamic property is called as entropy. Spontaneity means naturally occurring process, that is called as a spontaneous process. Here the relation between entropy and spontaneity, you know, solid ice means ice is melt and converted into liquid. That time that ice is absorb the heat from surrounding and converted into liquid. In solid water, here H2O, solid. That solid water absorbs the heat from surrounding at about 0 degrees Celsius, and here that solid water is converted into liquid, and this water liquid again taken heat from surrounding above our heat supply to this water liquid, and that water is boiled, means is converted into water vapor, means gaseous state at 100 degrees Celsius, and this process is 0 degrees Celsius. And this process is a spontaneous process. And this is the natural process. Such types of processes we see in entropy and spontaneity. Another example is H2O2. means hydrogen peroxide, H2O2, here twice H2O2 gas. Here this gas is converted into twice H2O liquid plus O2 gas. Here the two molecules of H2O2 is converted into three molecules. Here two molecules of water and one molecule of oxygen. And here the entropy of this H2O2 is increases, means randomness is increases, and delta S of this reaction is plus 123 kilojoules, and value of delta S is greater than 0, and the process is a spontaneous process. Means here the randomness is increases, disorder is increases. That time the reaction means the value of delta S is positive. Another example here, H2O2 means hydrogen gas, H2 gas plus H2 gas plus O2 gives out H2O, means twice H2O. Here this is the gaseous for hydrogen molecules in gases, for oxygen molecule in gases. These are two molecules are combined together and for liquid. That the randomness or disorder is decreases. Disorder is decreases, and disorder increases. And delta S value is negative, minus 327 kilojoules, and delta S is less than 0. This value is negative. Here this reaction takes place in spontaneous. The randomness here is decreases, disorder decreases, but the reaction is spontaneous. Another case, back case, we see H2O2 is converted into water and oxygen gas. That time the randomness is increases, entropy also increases. Randomness increases, entropy increases. Randomness decreases, means that molecule is comes in ordered manner. That time entropy is decreases. Here that is not exact, the spontaneity. Here first case is randomness increases, second case the randomness decreases. But both in cases the reaction is spontaneous. And then the second law of thermodynamics depends upon, you know, the first law of thermodynamics, then we see the second law of thermodynamics. The second law of thermodynamics, total entropy. Second law of thermodynamics. Thermodynamics means system and its surrounding. Here we see the total entropy of the system and surrounding. Total entropy of the system and surrounding increases in spontaneous process. This is the second law of thermodynamics. Number of times this question is asked on this point. State second law of thermodynamics that the total entropy of the system and surrounding is increases in spontaneous process is called as a second law of thermodynamics. And here the delta S total. Delta S total means delta S total is equal to delta S system plus delta S surrounding. Delta S system plus delta S surrounding is greater than 0. Is greater than 0. And here there are different cases. Here the value of delta S is greater than 0, the value of delta S is less than 0, or value of delta S is equal to 0. These are the cases of spontaneity and entropy. Here delta S first. Delta S total is greater than 0. Delta S total delta S is change in entropy is greater than 0. That type of process is spontaneous. This process is spontaneous process. Then second case, delta S total is less than 0. It's less than 0. The process is non-spontaneous. The process is non-spontaneous. Then third case, delta S is equal to 0. Then the process is in equilibrium state. Equilibrium state. These are the three cases. Here is the relation between entropy and spontaneity, and in case second law of thermodynamics is state that the total entropy of the system and surrounding is increases in spontaneous process. Here delta S total is equal to delta S system plus delta S surrounding greater than 0. And here these are the spontaneity and non-spontaneous process. Here delta S total is greater than 0, that time the process is spontaneous. Here delta S total is less than 0, the process is non-spontaneous. And delta S is equal to 0, the process is in equilibrium. These are the different value of spontaneous and non-spontaneous depend upon entropy, depends upon the temperature and number of factors here. And then we see Gibbs energy. The next point is Gibbs energy. The Gibbs energy is denoted by letter G. And this is the new term in a thermodynamics, that is the Gibbs energy. Gibbs energy. And this is related to the spontaneity. Gibbs energy. Gibbs energy is denoted by letter Z. Here you know the spontaneity. Is spontaneity of the system is the term in a thermodynamics. In a thermodynamic problem. And that property, because that problem is solved by American scientist Gibbs. And he introduced a term Gibbs energy, and this is denoted by letter G. This is denoted by letter G. The Gibbs energy is defined as G equal to, G means Gibbs energy, and definition of Gibbs energy is equal to, G is equal to H minus TS. Here in this case, this is the definition of Gibbs energy. This is the definition of Gibbs energy. G means Gibbs energy, H means enthalpy, T means temperature, and S means entropy. And then change in entropy. Here also, the Gibbs energy is called as a state function. And Gibbs energy is depend upon enthalpy, temperature, and entropy. These are the state function, hence Gibbs energy is state function. Then change in Gibbs energy is denoted by delta Z, means change in Gibbs energy is denoted by letter delta Z, means change in Gibbs energy, is equal to delta H, change in enthalpy, minus T into delta S, T means temperature, into delta S, change in enthalpy. This equation is called as a change in Gibbs energy. Change in Gibbs energy means delta G is equal to delta H minus T delta S. Delta G means change in Gibbs energy, delta H means change in enthalpy, then T means temperature, delta S means change in entropy. And then next point, Gibbs energy and spontaneity. Gibbs energy and spontaneity. Gibbs energy and spontaneity is the next point. Gibbs energy and spontaneity. Gibbs energy and spontaneity. Here the Gibbs energy is equal to G is equal to H minus Ts. This is the definition of Gibbs energy. Then change in Gibbs energy means delta G is equal to delta H minus T into delta S. Then the total entropy change in a process is given by delta S total. Delta S total means total change in entropy in the process is equal to delta S system plus delta S surrounding. Delta S system plus delta S surrounding. Delta S surrounding. And we calculate the total entropy change is equal to entropy change in system plus entropy change in the surrounding according to the definition of second law of thermodynamics. And here delta S of the system is a system is a removed, and here the total delta S total is equal to delta S plus delta S surrounding. Delta S total is equal to delta S, the delta entropy of the system plus entropy of the surrounding, and calculate with the total entropy of the system. And then next we see the relation between delta Z and delta H. The relation between delta Z and delta H means a relation between the change in enthalpy and change in entropy. Sometimes this relation is asked in the exam, relation between delta Z and delta H. A relation between delta Z and delta H means change in enthalpy and change in entropy. You know the delta Z means change in enthalpy and total entropy is equal to of the system is equal to delta S total is equal to delta S means change in entropy of the system plus delta S sum. This is the total entropy of the system is equal to entropy of system plus entropy of sum. And here delta S total is greater than 0. Greater than 0 means that the greater entropy. Then if delta H is a change in enthalpy of the system, and the enthalpy change in surrounding is a minus delta H. Here delta H change in enthalpy of the system and minus delta H change in the enthalpy in surrounding, and hence delta S surrounding is equal to minus delta H upon T. Minus delta H upon T. Substitute this value in this equation. Substitute this value in equation number first. Here delta S total is equal to delta S total is equal to delta S means change in entropy of the system minus delta H upon T. Delta H upon T. This is the delta S total means change in entropy. Total entropy change is equal to entropy change of the system minus delta H upon T means change in entropy, change in enthalpy of system is equal to change in entropy. Then substitute this value. Rearrange this equation. Means T delta S total here T delta S total. Rearrange this equation. T delta S is equal to delta S. T delta S is equal to delta H minus T delta S. Here this is the equation number first, this is the equation number second, and then you know the change in Gibbs energy is equal to delta G is equal to delta H minus T delta S. This is the change in Gibbs energy. And compare this equation to N3. Compare equation to N3. We get T delta Gs, but delta Z is equal to minus T delta S delta Z is equal to minus T delta S. And here this is the relation between delta Z and delta H. And this is related with each other. And the value of delta S and delta Z decided the process is spontaneous or non-spontaneous. Here there are different cases according to the second law of thermodynamics. The first case, The first case, delta S total is greater than 0 and delta Z less than 0. The process is spontaneous. Spontaneous. This is the first case according to the second law of thermodynamics. Then second, opposite this. Delta S total is less than 0 and delta Z is greater than 0 and the process is the process is non-spontaneous, opposite of the spontaneous. Non-spontaneous. Then third case, according to the second law of thermodynamics, delta S is equal to 0. Delta S is equal to 0 and delta Z is equal to 0 and the process is in equilibrium. And this is the relation between delta H and delta Z. Here delta, the relation. Sometimes question is asked on this. Derive the relationship between delta Z and delta H. And we start the derivation from second law of thermodynamics. The second law of thermodynamics means total entropy of the system and surrounding is increases in spontaneous process. I start from here. The delta Z is change in enthalpy and minus delta H means change in entropy of the surrounding. And the surrounding means the delta S surrounding is equal to minus delta H upon this value is substituted in this equation. And you start solve the equation. And you know the equation of change in Gibbs energy, that is delta Z is equal to delta H minus T delta. And compare these two equations and solve this derivation. And here today we rest